Welcome to the lecture 6 of digital electronic circuits ET206. In this lecture, we will deal with first one, one's complement arithmetic. One's complement arithmetic, and second one is we will deal with two's complement arithmetic. So coming into first part, that is one's complement arithmetic. One's complement arithmetic. Okay. So here what I have to do is, suppose you have two numbers to subtract, a minus b. You have to take one's complement of b, say a, and here a and b both are binary numbers. So you have to take one's complement of b, and then add it to a. So you have to do a plus one's complement of b, and if a carry comes in the result, if carry exists, then add the carry which gives the final result. Again, after that you look to the most significant bit of the result. If MSB is 0, which means the result is positive. In sign. Whereas if MSB is 1, then the result is negative in sign. Okay. So you have two binary numbers A and B. So B needs to be subtracted from A. So first you take one's complement of B, then add it to A. So A plus, step 1 is take one's complement of B. Second step is add A to one's complement of B. And in that, if carry exists, then add the carry to the final result. Okay. Otherwise, if there is no carry, leave it. Now, now come to the result. If MSB of the result is 0, then the result is positive in sign. Whereas if MSB is 1, then the result is negative in sign. Okay. So let me do some example based on example of one's complement arithmetic. After that we will deal with two's complement arithmetic also. One's complement arithmetic. Okay. So here there is one more addition. You can have plus or minus form. Yeah. It is a plus or minus. In both cases it is right. It is plus or minus. Yeah. Now coming to the first question. Subtract 14 from 25 using 8 bits one's complement algorithm. 8-bit one's complement algorithm. Okay. So what I need to do is 25 minus 14. That is what I have to get. So actually, what is 25 minus 14? 25 minus 14 is 11. Okay. So you need to get 11 as answer plus 11. Okay. Now first you convert 25 to binary. So it is 25 by 2. 25 by 2 is 12 with the remainder 1. Again divided by 2, 6. Remainder is 0. Divided by 2, 3. Remainder is 0. Divided by 2, it is 1. Remainder is 1. Divided by 2, 0. Remainder is 1. Therefore 25 to the base 10, you can write it as, right from bottom to top, that is 1 1 0 0 1. Okay, so how many bits are there? 1 2 3 4 5. So you add 3 zeros to the left side, so that is 25 to the base 10. 25 to the base 10 is, this is the 8-bit representation, that is 0 0 0 1 1 0 0 1 to the base 2, that is the 8-bit representation. Again 14, convert it into binary. 14 by 2, that is 7, remainder is 0, divided by 2, that is 3, remainder is 1, divided by 2, 1, again remainder is 1, again divided by 2, 0, remainder is 1, right from bottom to top. So 14 to the base 10 is 1 1 1 0. So that is already 4 bits. So add 4 with 0 before in the starting point. So that is 14. Okay. So you have got 25 to the base 10 as well as 14 to the base 10 in binary format. Now you take 1's complement of 14 to the base 10. So what is it? So that is given by 1 1 1 1. Okay. 0 becomes 1, 0 becomes 1, 0 becomes 1, 0 becomes 1. Then 3 zeros, 0 0 0 1. Okay. So that is 1's complement. Now add this 1's complement to binary of 25. Okay. So what is binary of 25? Binary of 25 is 0 0 0 1 1 0 0 1 0 0 1 plus, here what do we get? Double 1 double 1, get 1 1 1 1 double 1 double 1 0 0 1 0 0 0 1. Okay, so this is basically 25 to the base 10, and this is 1's complement. 1's complement of 14 to the base 10. Okay, so if you are adding these two, 1 plus 1 is 0 with a carry 1, 1 0 1, 1 plus 1 is 0 with a carry 1, 1 plus 1 is 0 with a carry 1, 1 plus 1 is 0 with a carry 1, 1 plus 1 is 0 with a carry 1. Okay, so what is the final answer? Now see, here you are getting the carry, so you need to add that carry. So plus 1 here, so I will add that carry here. So what is 0 plus 1? 1 1 0 1. Again you will get 4 zeros, 1 2 3 4. Okay, therefore we can write 25 to the base 10 minus 14 to the base 10 is equal to 0 0 0 0 1 0 double 1 to the base 2. So since carry is there, you have to add the carry. Okay, that is all. Now if you are converting it into a decimal number, how would it be? You give the positions first. Is 0 1 2 3 4 5 6 7. Therefore we can write it as 1 into 2 cube plus 1 into 2 power 1 plus 1 into 2 power 0. What is it? That is 8 plus 2 plus 1. Answer is 11 to the base 10. Okay. So this is how you are subtracting. And again, since here the MSB is 0, here the MSB is 0 means the sign is positive. Okay. Now coming to the second question. Add minus 25 and plus 14 using 1's complement method. Okay. So here we are going to do 14 to the base 10 minus 25 to the base 10. Okay. So already we have derived the binary count of 25. 25 to the so where did you go with 8 bit? Okay. You can go with 8 bit. 8 bit. Okay. So what is 25 to the base 10? 25 to the base 10 is 0 0 1 1. 25 to the base 10 is triple zero double one triple zero double one double zero one to the base 2 double zero one to the base 2. So what is ones complement of it? Ones complement of 25 to the base 10. That is given by 1 1 1 double zero 1 1 0. It is again to the base 2. Now what is 14 to the base 10? 14 to the base 10. That is given by what is 14 to the base 10? If you are good looking back, is double zero double 1 0. Is double zero double 1 1 1 0. Okay. Now you add these two. So I am just going to add 1 1 1 double zero 1 1 0 plus 0 0 0 0 1 1 1 0. Add these two. So 0 plus 0 is 0. 1 plus 1. 1 plus 1 is 0 with a carry 1. 1 plus 1 plus 1 is 1 with a carry 1. 1 plus 1 is 1. Sorry, 1 plus 1 is 0 with a carry 1. 1 1 1 1. Okay. Here the MSB is 1. Therefore the answer is negative. Okay. MSB is 1. Therefore the answer is negative. Okay. So here what we get? So here the final answer is 14 to the base 10 minus 25 to the base 10. What is it? That is 1 1 1 1 0 1 0 0 to the base 2. So how will you convert it into a decimal format? You give the positions. So this is 0 1 2 3 4 5 6. Okay. So we can give 6 for okay. Now here see one clarification is there. Here don't give positions directly. Okay. See here MSB is here. If MSB is 1, you have to take the ones complement of it. Okay. So that means what is ones complement of this one? That is 0 0 0 0 1 0 1 1. Take since MSB is 1, you have to take the ones complement. That is a step I have forgot here. Okay. So if MSB is 0, result is positive in sign. Whereas and finally takes the ones complement of the result. You will get the answer. Ones complement of the result. That I have forgotten the step here. Yeah. Now coming to this one. Okay. Since the MSB is MSB is sorry that is when MSB is 1. When MSB is 1, you have to take the ones complement of the result. So result is negative in sign, so you have to take the ones complement of that result and give the decimal value. Okay. So what is it is? So if you are taking the ones complement, of the result, you will get like this. Now you give positions. That is 0 1 2 3 4 5 6 7. Therefore the final answer in decimal format is d to the base 10. D we don't know. You need to find the value of d. That is 1 into 2 power 3 plus 1 into 2 power 1 plus 1 into 2 power 0. What is it? It is 8 plus 2 plus 1. That is 11. And since the MSB have found before doing the ones complement is 1, the answer is negative. So answer is minus 11. That is again to the base 10. So that is how we are adding with ones complement. So we will do with one more example. Third one. Third one is add minus 25 and minus 14. Okay. So here both the numbers are negative. Therefore you need to take ones complement of both. You take ones complement of both. Okay. And the rest is remaining the same. Therefore, since we are taking the ones complement of both, the result will be also in ones complement form. Will be also in ones complement form, and you have to take to get the final answer. To get the final answer, you need to take ones complement of the result. Ones complement of the result. Okay. So what is minus 25? So first you go for 25 to the base 10. What is it? 25 to the base 10 we have found it as So again the 00011. It is 00011 to the base 2. Therefore, minus 25 to the base 10 in ones complement format is 11100 110. That is in ones complement form. That is in ones complement form. Okay. Again, 14 to the base 10. What is it? 14 to the base 10 is 1110, and you add 4 zeros before that. Okay. Now take minus 14 to the base 10. That is in ones complement form. We will get 1111 to the base 2. That is again in ones complement form. Ones complement form. Now we add these ones complement. So that is 1110, 110, and this one and this one. 1111 0, 0, 0, 1. So you need to add these two. 0 plus 1 is 1. 1 plus 0 is 1. 1, 0. 0 plus 1 is 1. 1 plus 1 is 0 with a carry 1. 1 plus 1 plus 1 plus 1 is 1 with a carry 1. So this is again with a carry 1. So you need to add that carry. So add the carry here. So the final answer will be 1 plus 1 is 0. 1 plus 1 is 0 with a carry 1. 1 plus 1 is 0 with a carry 1. 1 plus 1 is 0 with a carry 1. 1 plus 0 is 1, 1, 0, 1, 1. Now see, here we can see that the MSB is 1. Okay. Now since the MSB is equal to 1 in the result, since the MSB is in the or is 1 in the result, the answer is negative in sign. The answer is negative in sign. Therefore, we can add. To get the final answer, we have to get the ones complement of the result. So this I can take it as the result and take the ones complement of the result. So what is it? So result we can write it as result. We can write it as 111011 111011 00. Okay, that is the final result what we are having. Now what you need to do is, you need to take the ones complement of the result. Ones complement of the result. What is it? That is 001 00 111. Yeah. 001 00 1 2 3 4 5 6 7 8. Yeah. Now we will give the positions of it. This 0, 1, 2, 3, 4, 5, 6, 7. So if you need to get the decimal equivalent of it, what is it? That is 1 into 2 power 5, then plus 1 into 2 power 2, then plus 1 into 2 power 1, and the last one is plus 1 into 2 power 0. So what is 2 power 5? That is 32. This 2 power 2. 2 power 2 is 4 plus 2 plus 1. So what is the answer? It is 36 plus 2 plus 1. So answer is 39. And since the MSB of the answer is 1, we should give the negative sign. So the answer is, so the final answer will be final answer is minus 39 to the base 10. Okay. So hope you have understood how to perform the calculations. Okay. Now, again, if you are doing with if I am doing with another two numbers, say as question I will give it as fourth question. And is add plus 8 and plus 2 using ones complement arithmetic. So I am giving a very simple example, arithmetic in 4-bit form. Okay. So you can write 8 to the base 10 is 100 to the base 2, and 2 to the base 10 you can write it as 0010 to the base 2. Okay. Now, if you are adding plus 8 and plus, so here you need to add. If that is a thing, you have to take both the things in ones complement format. So you can write ones complement of 8 to the base 10. What is it? That is 0111. And what is ones complement of 2 to the base 10? That is 0010. Now add the ones complement. Okay. So 1 plus 0 is 1. And 1 plus 1 is 0. 1 plus 1 is 0 with the carry 1. 1 plus 1 is 0 with carry 1. So that is 1 0 1. Okay. Now here what happens is that the MSB becomes, yeah, okay. So if it is positive, no need to mind the MSB. Now it is 1001. That is in ones complement form. So that is, yeah. Now if you are having two positive numbers, how will you convert it into a decimal number? You add 1. So what is it? That is becomes 1010. Okay. So that will be the final answer. Okay. So because since the MSB is 1, you can add that MSB here. So the answer is 1010. And if the answer is 1010, what you can get is 10 to the base 10. And here this is positive. Okay. Now see here no need to see if both numbers are positive, no need to take care of the MSB part. Okay. If both numbers are positive, no need to take care of the MSB part. Okay. Yeah, so that is it. But since this is ones complement, you need to add 1 to ones complement. Then you will get two's complement. You will take the direct two's complement of that. Okay. So that is in question number 4. Now, yeah. Now coming into next. Now, okay. So with that, I am ending with the ones complement arithmetic. So I have done with almost all the steps in ones complement arithmetic. Now next one is I am going to deal with two's complement arithmetic. I'm going to deal with two's complement arithmetic. Yeah, coming into two's complement arithmetic. Two's complement arithmetic. Okay. So what is the easy way to find the two's complement? Two's complement is basically ones complement plus 1. Okay. So here I will give you an example. Okay. Then it will be clear. Subtract 14 from 46 using two's complement arithmetic. Okay. So you need to find 46 minus 14. That is same. So here what you have to write is, you have to write 46 in binary form. 46 you need to write in binary form, and 14 you need to write in 2's complement form. Okay, so I will write 46 in binary form. 46 by 2, that is 23. Remainder is 0, divided by 2, you will get 11, remainder is 1, divided by 2, 5, remainder is 1, divided by 2, 2, remainder is 1, divided by 2, 1, remainder is 0, divided by 2, 0, remainder is 1. And you have to do it, okay, now, so this is 1, 2, 3, 4, 5, 6. So you can go with 8-bit arithmetic, right? So you can write with, I will deal with 8-bit arithmetic. Okay, so how do I write 46 to the base 10? 46 to the base 10 I can write it as 1, 0, 1, 1, 1, 0. So you have 6 bits, so add 2 bits. So that is 46 to the base 10. Now, next one is 14. So what is 14 to the base 10? 14 to the base 10 is 1, 1, 1, 0 to the base 2. But you need to make it 8 bit. 3, 4. Yeah. Now, take how to take 2's complement of 14 to the base 10. First you take 1's complement and add 1. 1's complement of 14 to the base 10. That is 1, 1, 1, 1, 0, 0, 0, 1. You add 1. So what is it? 1 plus 1 is 0 with a carry 1. So 1, 0, 0. You will get 1, 1, 1, 1. Okay. So this is basically 2's complement. 2's complement of 14 to the base 10. Okay. Now you add the binary of 46 and 2's complement of 14 to the base 10. Okay. So you can write 46 to the base 10. What is it? 46 to the base 10 is the 0, 0, 1, 0, 0, 0, 1, 0, 1, 1, 0, triple 1, 0, 1, 1, 1, 0, plus what is minus 14 to the base 10? That is basically the 2's complement of base 10. Okay, that is 4, 1, 0, 0, 0, 1, 0. 4, 1, 0, 0, 1, 0. 4, 1, 0, 0, 1, 0. Yeah. Now you can add. You are adding 0 plus 0, 0. 1 plus 1 is 0 with the carry 1. 1 plus 1 is 0 with the carry 1. 1 plus 1 is 0 with the carry 1. 1 plus 1 is 0 with the carry 1. 1 plus 1 plus 1 is 1 with the carry 1. 1 plus 1 is 0 with the carry 1. 1 plus 1 is 0 with the carry 1. Here it is a carry. So here we can ignore the carry. Ignore the carry. Okay. So that is a specialty in 2's complement of that. You can ignore the carry. Here the carry is ignored. Okay. Now, therefore, what is the answer? So we will try to give the answer. So it is 46 to the base 10 minus 14 to the base 10. That is given by 0, 0, 1. 0, 0, 1 and 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 zeros. Okay. Now we give the positions of it. Okay. So that is 0, 1, 2, 3, 4, 5, 6, 7. So if you need to find the decimal equivalent, what is it? That is 1 into 2 raised to 5. What is 2 raised to 5? 32. So answer is 32 to the base 10. That is how we are dealing with 2's complement arithmetic. Okay. Now, again, yeah, so I think you have understood how to subtract 46 minus 14. That means you will get the result as positive. So next question. Second example, add minus 75 and plus 26 using 8-bit 2's complement arithmetic. 8-bit 2's complement arithmetic. Okay. So here you need to get 26 minus 75. Okay. So you already know that the answer will be negative. Okay. So that is the first impression what we are having. Okay. Now first you convert 75 to binary. So 75 to the base 10. 75 to the base 10. I'm not going to give the entire steps. So 75 to the base 10 is given in 8-bit. Is given by 0, 1, 0, 0, 1, 0, 1, 1. Okay. So take that. Take the ones complement of that. Ones complement of 75 to the base 10. That is given by 1, 0, 1, 1, 0, 1, 0, 0. Now how to find 2's complement? 2's complement of 75 to the base 10. That means you add 1 here. So you get 1, 0, 1, 0. Here you get 1, 0, 1, 1. Yeah. So that is the 2's complement of 75. Now take 26. So 26 to the base 10. You can directly convert it into binary. That is in 8-bit form. It is 0, 0, 0. 1, 1, 0, 1, 0 to the base 2. Okay. So here that conversion I am not showing. Now add these two. Add the binary and 2's complement of 75. So that is 0, 0, 0, 1, 1, 0, 1, 0. That is 26 plus 2's complement of 75. 75 to the base 10 take its 2's complement. 2's complement. You will get 1, 0, 1, 1, 0, 1, 0, 1. Okay. So the 0 plus 1 is 1. 1 plus 0 is 1. 1, 1. 1 plus 1 is 0 with the carry 1. 1 plus 1 is 0 with the carry 1. 1, 1. So here what you are getting is MSB. You are getting MSB is 1. Since MSB is equal to 1, you can infer that the result is or the final answer is negative. Now, and also that is no carry here also. Okay, since there is no carry, you can directly convert. So how to directly convert? How to directly convert means since it is MSB is 1 and result is negative, you need to take the 2's complement. You need to take the 2's complement of the final answer. Okay. If MSB is 1 and answer is negative, this is the result. And to get the final answer, final answer is 2's complement of result. Okay. So what is the result? 1, 1, 0, 0, 1, 1, 1, 1. So take the ones complement of it first. So take the ones complement of R result. That is 0, 0, 1, 1, 0, 0, 0, 0 plus 1. That gives the 2's complement. So that is 0, 0, 1, 1, 0, 0, 0, 1. So you can write it as the final answer is You can write it as 0, 0, 1, 0, 0, 1 to the base 2. Now give the positions. So given the positions, it is 0, 1, 2, 3, 4, 5, 6, 7. So if you need to find the decimal answer, it is 1 into 2 raised to 5 plus 1 into 2 raised to 4 plus 1 into 2 raised to 0. So what is the answer? Answer is 32. It is 32 plus 16 plus 1. It comes to 49 to the base 10. And since the MSB of the result is 1, you can give the answer as negative. So the answer is minus 49 to the base 10. Okay. So hope you have understood the 8-bit 2's complement arithmetic. Okay. Now we will do one more question also. using the fractional part. Okay. So question is add minus 45.75 to plus 87.5 using 12-bit 2's complement form. Using 12-bit 2's complement form. Okay. So what is basically 87.5? 87.5, if you are converting it into binary, I am not going to do the entire calculation. So 87.5, if you are taking it into binary, you will get it as 0 1 0 1 0 1 1 1 .1000. This is the base 2. Again, if you are taking the 2's complement form of minus 45.75, you are taking the 2's complement form of minus 45.75, it will be 1101 0 0 1 0 0 1 0 0 1 0 .0 1 00. Okay. And if you are adding these two, you will get it as 0.1100. 1 plus 0 is 1, 1 plus 1 is 1 with a carry, 1 plus 1 is 0 with a carry 1, 1 plus 1 is 0 with a carry 1, 1 plus 1 is 0 with a carry 1, 1 0 with a carry 1, so here you will get carry. Okay. So here this is the carry, so we can ignore the carry. So this is basically the 2's complement. This is basically the 2's complement of 45.75 to the base 10. That means first you need to convert it into binary, then find the 1's complement and add 1 to it. Okay. That step we have to do yourself. Okay. And again, here what is this? Here MSB is 0. Since MSB is 0, you can infer that the result is positive. And the given result is in normal binary form. Okay. Therefore, we can write final answer as 00101.1100. So that is the final answer. And if you are finding the positions, you will get it as 0 1 2 3 4 5 6 minus 1 minus 2 minus 3 minus 4. So the answer will be 1 into 2 raised to 4 plus 1 into 2 raised to 3 plus 1 into 2 raised to 0 plus 1 into 2 raised to minus 1 plus 1 into 2 raised to minus 2. So this will account to almost 41.75. So it is plus 41.75 to the base 10. Okay. So with that, I am ending with the concept of 1's complement and 2's complement. Okay. 1's complement and 2's complement addition. So in this lecture, what we have dealt with is 1's complement and 2's complement arithmetic. Yeah. So we have generally dealt with 1's complement arithmetic and how to add and subtract using 1's complement arithmetic. Then we have done with 2's complement arithmetic, how to add and subtract using this 2's complement arithmetic. Okay. So with that, I am ending with lecture number 6. I think it is 6. Yeah. Lecture number 6. Okay. So in lecture number 7 will be okay. So almost the conversion part is over. So in the next lecture, in lecture number 7, we will be dealing with how to perform the code conversion, and after that we will start with the codes. that will be dealt in exam number 7. Thank you.